Joining us on this week's podcast is Matt Hallberg. Matt, how are you doing, buddy?
Surviving, just
It-
looking around for coronavirus.
well, I know you were just in Japan. Now you're with Kioxia. Kioxia, come on, say it for me.
Kioxia.
Kioxia, former Toshiba storage group. So I'm sure you spend quite a lot of time over there. How was that trip?
It was great. I mean, everyone was wearing masks. Everyone had a hand sanitizer everywhere. And when I say great, I mean it was great in that the culture hadn't, everyone's still running around doing their thing. It was not so great in thinking about coming back to the U.S. and, uh, you know, if I was infected or not. All the hysteria is scary when you're in Japan. All the hysteria going on in the U.S.
Oh yeah, I'm sure it is. You're okay though, right? You're not feverish or anything.
No, but I've got to wait 2 weeks.
So
So on a self quarantine.
good. I'm not going to talk. I'm not going to come visit you then for some time. All
No
right.
hot chicken.
Yeah, that was good. There's a great chicken place north of Denver. All right, so we've got a lot going on with your company, but the stuff that you're involved in is bigger than just Kioxia. We've got uh, an announcement that you guys made last week around new SSDs. The thing that we're excited about is PCIe Gen 4 and also the U.3 form factor. So I want to break down those two things separately and have you speak. You can speak of your product for sure, but more as a diplomat for those two organizations because I think it's there's just a lot of not even misconceptions, just people don't know what Gen 4 is capable of for storage, and U.3 is net new for probably 95% of the world out there. So which one do you want to start with?
Let's start with U.3,
All right.
if that's okay with you.
So U.3 is the same shape as U.2, yeah? What's new?
So it's the same. It's physically the same connector, same drive shape. So it's a 2.5-inch drive. Uh, the main difference is a pin that's used on a backplane that supports tri-mode. Tri-mode being HBAs and backplanes from Microsemi and Broadcom that can natively talk PCIe, SAS, or SATA to any SSD. So you plug in a SATA SSD, it'll talk SATA. You plug in an NVMe SSD, it'll talk NVMe, all within the same backplane. And so there's this little connector, the drive receptacle that basically says, is this a universal backplane? Universal meaning it can talk SAS, SATA, NVMe. And if it is, our drive detects that pin is high and says, oh, okay, cool. I can talk to you guys in U.3 mode.
Okay.
If it isn't high, then it's just a regular NVMe backplane, and we talk to that NVMe backplane just as we would a U.3 backplane. Same NVMe protocol, same commands, everything else.
So I know we've seen PowerEdge and probably Lenovo and others that have had NVMe backplanes that can talk SAS SATA, but is that more proprietary? You're saying this is more of an open standard?
Yeah, yeah. I mean, it's the micro semi and the Broadcom stuff. The tri-mode HBAs are generally available to everybody. It's really up to the OEMs on implementing them within their own server and storage SKUs. So now that the spec is out there, now that there's a drive ecosystem that's in motion, so we're one of the U.3 drives, or there are other U.3 drives that presumably be coming to market soon, and hopefully there's enough of us out there supporting it that will drive um, mainstream support for it.
So functionally, though, there's really no reason for you guys to ever go back to U.2, right? If it will work with all backplanes.
Right. Yeah. From a drive perspective, functionally, there's nothing that should keep us from going back to U.2. I mean, for us, for anyone doing U.3, you've got to have some considerations on the number of PHYs that you have on the inside of the drive. You got to be able to basically support 6 PHYs. And that way, you could talk to a U.2 backplane or a U.3 backplane. The PHY port mapping is a little bit different between the two, but aside from that, there's no real reason, unless you're designing a data center drive that is really focused on cost, and if you got to worry about the form factors, if you're doing E1S or M.2. In general, if you add more PHYs, that can increase your system on chip, your SoC size. And if your SoC size is too big, then you won't fit an M.2 or E1S.
Okay.
Um,
It
that was a long way of answering your question, though.
Are there any other benefits? Is there anything else that would be discernible to an end user about where U.3 would offer any upside?
Yeah, I mean, my dream, and I think the dream not just mine but shared by others of U.3, is really for like small medium businesses, right? So today, if you wanted to buy a system for general purpose storage, right, doesn't need to be fast, just needs to have a lot of terabytes. Um, you could go off and buy a system that has a bunch of SATA and SAS disk drives spinning media, or higher capacity SATA SSDs or SAS SSDs. And then if you needed to buy a performance tier for, say engineering, or if your business is doing like rendering or things like that, you need to go buy a separate server dedicated to that with faster media like NVMe. What this universal backplane allows you to do is actually take a single server and configure it any way you want. So you can go buy a 15 terabyte hard drive from Toshiba, maybe. You could go buy SATA SSDs, SAS SSDs, and then you could buy NVMe SSDs and throw them all into the same system. So inside of one server, now you have your performance tiering. You have your hard drives for cold data. You've got your SAS and SATA drives for maybe caching or warm data. And then for those high-end performance guys, you've got NVMe. And that's without having to buy multiple systems. It's all in the same system. So at that point, it just becomes a software layer application of, assigning work group A that just basically, does write once, read many onto the hard drives, and then, the other applications applicable to the other drives.
Yeah, so at a certain point, it makes system design easier, and now we're just buying drives based on need rather than interface or, well, that's it, right? What do I need from a performance or cost or capabilities perspective?
Yeah, I mean, as I've been in this industry, I've checked out various OEM websites, and they're all wonderfully designed. Let me just say,
Yeah, right.
they're amazing, right? In trying to create systems that had NVMe on there, there's like special tricks. You got to know what backplane to choose. And it doesn't always call out, this is for NVMe drives, or you don't always call out early in the configuration process, I want NVMe SSDs. So sometimes what happens is you start to create this configuration and you throw your mouse at the wall or something and saying, how do I add NVMe to this configuration? Why can't I add it? And that takes away the frustration, of having to find the right backplane that has NVMe and then having to find the right backplane that has SAS. Instead, that layer is completely absolved from you. You just, what CPU, what DRAM, what kind of storage, what
Right.
kind of OS. Boom, take my money.
So you're an enterprise guy. Do you see an analog for this on the client side? Is there a movement that you're aware of for U.3 to go into notebooks and IoT edge devices and PCs, things like that?
When you look at like the NUC, right? M.2s have been the prevalent or the popular
Right.
design option for client systems. You don't see really any U.2 drives in that arena. So while it'd be a fantastic idea for client-based systems, in general, like if you look at Intel chipsets, I'm not sure about AMD chipsets, but usually like on the South Bridge, you'll have a couple SATA ports. In general, everyone's going to NVMe on laptops because with NVMe, especially on the new client drives, you can get to SATA-like power reduction, and I think even better than SATA drives with some of the more later stuff that's been coming out. So the answer is, in my opinion, and my impression is no, we won't see it on client systems. More likely on workstations or servers.
Okay. So the other big thing is PCIe Gen 4. I know you and I have talked about this quite a bit around what these new servers enable. As you probably know, we've got a Lenovo platform in that supports Gen 4 on up to 16 bays. I think we're going to only end up with 10 or 12 in our final config, but that's pretty amazing. Non-blocking architecture, 16 NVMe PCIe Gen 4 bays in a 1U server. So as a storage guy, you've got to kind of be licking your chops at that opportunity. What do we see from a performance benefit or any other benefits in Gen 4 for SSDs?
I think there are multiple benefits. I mean, aside from the obvious benefits that everyone gets from graphics cards and GPUs, right, general purpose GPUs, the two other major arenas for system improvement are on the storage side, so the SSDs, and then on the network side, right? So um, the networking side, going from a 100 gig Ethernet NIC to a 200 gig Ethernet NIC, even if you're running an array of Gen 3 drives, you've just doubled your pipe, right?
Yeah.
So, in most cases, what I see with some servers is it's storage overload, where you have so much storage inside, so much performance that there's really no realistic way to get that storage outside of the box,
Oh, we
unless
have that debate all the time with people about, yeah, that's great that you can put all this in here. By the way, you unless you're only going to stay in this node, you can't do anything with it.
right. And so widening the pipes means that even if you have a system that has Gen 3 drives in it, but you have Gen 4 HBA and a Gen 4 NIC, you're able to realize more of the performance out of those drives. Of course, I would love for everyone to just move to Gen 4 drives, but that's not, that might take some time in terms of system availability and everything else. On the drive side, I've been in the storage industry for a while. I remember like 5 years ago. I think it was like 5 years ago that the golden number that was in every single storage appliance startup's press release was around 2 million IOPS. If you were playing like marketing bingo and you had to do a shot for certain terms, 2.5 million IOPS was instant shot. And what's fantastic about Gen 4 on these SSDs is, now you're going to get SSDs that are a by 4 interface, not a by 8 interface, but a by 4 interface that are going to do over a million IOPS.
Yeah.
And here is one server with two drives, and that server with two drives can do over 2.5 million IOPS. Welcome to 2020. Pretty crazy. So the performance benefits from an IO standpoint, right? Everything's doubled up a bit on sequential reads, sequential writes, random reads. Everything goes up. I think what makes sense for storage admins, IT admins, is file copies and things like that. If you have an IT infrastructure that's able to completely move over to Gen 4 from an SSD and from a NIC standpoint, if you're doing file copies, so we did a demo with a large OS company at Microsoft Ignite. I won't say who the OS company is, but the event was Microsoft Ignite.
Yeah.
They did a demo where they were copying over 1 terabyte files using a Gen 4 system. And they saw the performance was more than double across their system, and the amount of time used to transfer those files was less than half. So for IT admins or for people on an IT admin storage network, everyone hates having to copy files from like a SharePoint to their local storage or vice versa. And so there's a key features like, oh, hey, I just saved half the time. And if we're talking about 1 terabyte files, I mean, an application for that at these 8K files that you get from medical imaging are now easily 1 terabyte each. Now you can copy a bunch of 1 terabyte files over the network. Or, since we are in storage and we are doing high tech, if you're doing things like machine learning, the training processes require you to copy large sets of data over the network and over into the local storage. And so the faster you can go across the network and the faster you can get the data on the drives and the data between the drives and the GPUs, the more efficient your GPUs are going to be and the better realization of your investment. So I think Gen 4 is going to be amazing. All the big data words that are out there, big data, AI, machine learning, edge computing, that all requires lots of capacity and that all requires lots of performance. And Gen 4 is the perfect vehicle for all of that. And Gen 4 SSDs are definitely an enabler for realizing these big marketing terms.
All right. Well, we're pushing our my self-imposed time limit, but I do want to say you guys did launch the CM6 and CD6 last week. Since I wouldn't let you plug yourself, I'll plug you for you. you're you're over a million IOPS on both those drives, which is really cool. And I know the CM6 you guys are doing in a 30 plus terabyte class. Just before you go, a little bit about capacity. What are you guys seeing in terms of adoption of capacity in drives? It feels like to me the sweet spot is still probably in that 2 to 4 terabyte class, but are you seeing more demand for the larger drives?
Yeah, on the server side, we see mostly demand between 2 and 4. We have gotten a lot more people interested in 8, but 4 is the sweet spot. On the storage side, 8 has been the sweet spot. 15 is good, and 30 has been really non-existent, right? As I've been talking to customers about 30 terabytes and NVMe, there's been a lot more excitement. We see a lot of interest from the private sector on taking 18 storage racks and turning them into 9
Yeah.
storage racks by really moving the data, consolidating the number of drives. If you look at guys moving away from SATA into NVMe, I mean, you're buying a 4 terabyte SATA drive. You can buy an 8 terabyte NVMe drive and get rid of, if you had a server with 8 SATA drives, you can consolidate into 4 NVMe drives. So we see a lot of movement on higher caps, but the sweet spot is still 4 terabyte for server and around 8 terabyte for storage.
But you're still making the little ones. I guess there's still some demand for the small drives, even in the NVMe category for boot or logging or something.
Absolutely. I mean, there's a lot of guys out there who are buying 1 terabyte spinning media, and they want to find something that has similar capacity, or they're buying higher capacity HDDs, but they are still like, oh man, NVMe is so expensive, or an SSD is so expensive. So the easiest way for them to get into an NVMe drive or any SSD is to go after the lower caps. And so we still see lots of movement at the lower caps, especially on the data center side.
All right. Well, thanks for joining us today, Matt. Really appreciate your perspective on all these topics. And, again, thanks for stopping by.
Yeah, thanks everybody. Good talking to you, Brian.